All right, so we're starting key concept 2, and this is going to be day 1 of target 2A. This is rigid transformations. All right, so for your learning goals, I can identify the 3 types of transformations, understand prime notation, determine with accuracy the exact transformation and describe it using geometric terms, and finally, identify congruent sides of figures that are congruent. All right, so let's start with some vocabulary. All right, so a pre-image, you're going to be seeing lots of diagrams that have 2 figures in it. The pre-image is the original figure. The image is the new figure created by the transformation. The transformation itself is the operation that maps or moves the pre-image onto the image. Congruent figures. These are geometric figures that have the exact same corresponding side lengths and angle measures. So what I mean by corresponding is if I have a triangle that looks like this and I have another triangle, okay, and we're going to call this one ABC and we'll call this one DEF. And we're told that these 2 triangles are congruent. That means that if we're told that triangle ABC is congruent to triangle DEF, so this symbol right here, that's the symbol for congruence. So it looks like an equal sign, but it's got a little wavy symbol above it. Okay, so if the order is A, B, C, so this, and this, and then we're given D, E, F, that means that, like if you look at AB, that would be congruent to DE, so those parts would be congruent. If you looked at, say, BC, so this right here, in the same spot in the naming, so the middle and third letter of the second one, so those parts are congruent. And then finally, if you took like the last 2 letters of each one, that would be the third congruent side. And then for angles, which we're really not going to get into a whole lot this unit, but like angle B would be congruent to angle E, angle C would be congruent to angle F. So you see these marks I'm making, those show congruence. All right, and congruent sides. Those are corresponding sides of congruent figures that have the same measure or length. Okay, so that kind of gets into what I just showed you. So first, identifying transformations. Figures in a plane can be reflected, they can be rotated, or they can be translated to produce new figures. So a translation would be basically taking the shape, keeping the exact orientation, meaning you don't turn it at all, and you just slide it left or right or up or down. Rotation can be described as a turn. So that, see how we have the same figure and it's turning, and then a flip would be the reflection. So if you have a line, you basically, it'd be like looking in a mirror, you flip it over that. Alright, so here's how they look. So a reflection, so the blue image would be the pre-image, the pink would be the image. So what results after the transformation. So reflection, see how it kind of flips over that line until it finally looks like that. And it should be noted that whatever it's being reflected over, like this distance here and this distance, these would be the same distance. The distance between these 2 points, same distance. And then the distance from here to the ends, those are the same distance. Okay? Translation would be if you just took the figure and like that would be a slide right and then up. And then rotation would be like if I took it and rotated that 90 degrees. That would be counterclockwise. So remember, clockwise, like hands of clock. That's clockwise. Counterclockwise would go like that. So that's important to know. Because if you're given a transformation or a rotation, and you're told it rotates a certain amount of degrees clockwise or counterclockwise, that could make a difference in how the final image looks. And then prime notation. So the new position of an image's vertex can be written as A prime, and we basically reads as A prime. So if this is our pre-image here, and we're using the same letters instead of different ones, to differentiate between the pre-image and the image, we would just add a like an apostrophe. So it's we call that prime notation. So this is the original image. The new image is a, this one here, and each vertex that corresponds now has this prime notation after it. So let's take a look at our first example. So all we need to do is determine the type of transformation or transformations that took place from triangle ABC to triangle A prime, B prime, C prime. So it's important to note the notation that they use so you know which triangle you're starting at and going to. Now here all we're doing is asking you to identify the type of transformation. So in this case, notice how the B and the C have the same orientation. The figures look like if I took this one and moved it on top or vice versa, that they would be exact matches. So that would just be a slide, and if we were going to be specific, that'd be a translation that would be slid down, and then you would count, like if it asked for an exact measure, so it'd be down 1, 2, 3, 4, 5, 6, 7, 8, 9. So it'd be down 9, and then we'd count 1, 2, 3, 4 to the right. And all you do is you find the corresponding points, and you only need to do it once. So we don't need to do it for B and C because they would be exactly the same. So you just need to go from one point to the other matching point. So you wouldn't go from A to B prime, you'd go from A to A prime, or from B to B prime, or from C to C prime. All right, so now as far as congruence goes, remember what I said is that congruence is when the corresponding parts have the same measure. So we're told that WXYZ is congruent to JKLM. So let's just, what I would suggest doing until you get the hang of this is, okay, so this is our first, second, third, and fourth, and then go through J is first, K is second, L is third, and M is fourth. All right, so now what you need to be careful of, we're told that YZ is congruent to LM, and we're told that WZ is congruent to JM. All right, so you don't want to make any assumptions and say, well, you know, based on this, then this has got to be the congruent part. Obviously, this figure's been rotated, so pay attention to how these are. So you can go back and, like you have that numbered, you can say, okay, so this is 1, 2, 3, 4, and then over here we have 1, 2, 3, 4. All right, so our remaining sides, we've taken care of this one and this one. Let me change the color back. So we've got those two. So what we need is this, and what is that corresponding to? So notice it goes 1, 2, so it's going clockwise around. So we can say that WX and JK are congruent, and then our final sides would be XY and LK.